Can you all hear me, please? Okay, good morning, everyone. Yeah, welcome back to a new session, another session on the back-end application development. Sorry, we're a bit late behind schedule. As a result of that was as a result of a little bit of technical challenges. I'm so sorry about that. But without further ado, we are going to go on to the session. So please hold on for a little because I'm trying to migrate from another system. Because the initial system I got to use was given a little bit of challenge. So I'm trying to migrate. Okay. So sorry for delaying your time. Okay.
It is time for you to go and Mr. Ayat to the office. It's fine, you can leave them and be able to handle it. Sorry? Oh, no. He hasn't called me. In case he calls you, you are free to. Oh, he has already gone?
Okay, so please, can you see my screen at the moment? Hello, please, can you see my screen?
Identity matrix I. So if I say np.I is 4, see, do the algorithm. Just create.
All right. Good morning, all. Good morning. You're most welcome. Welcome to this new session. So today we'll be talking on.
Good morning, all.
Today we'll be talking on databases from the back end application development. Yes. So if you recall the previous classes, initially in this particular module, the back end application technology, at the initial session, we looked at components of back-end application development, which we mentioned. We have programming languages, right? We have API, application programming interface. We have database systems, and we have servers before databases. So previous sessions we looked at servers. Previous theoretical sessions we looked at servers. We look at application programming interfaces, the APIs, and then now we are going to be looking at database. I'm aware that you have a course on its own on database. Yes, but for that, I'm mostly aware that you'll be looking at RDBMS, Relational Database Management System. Yeah, this is just one type of database, actually. There are a lot of databases available out there. We like in the major categorization, we have SQL database, right? And we have no SQL databases. Yeah. So without further ado, today we'll be looking at databases actually. So first of all, we start by looking at the outline of today's session. So we'll be looking at introduction, right? Introduction of database. We'll be looking at uses of database, as well as types of database, as well as also the components of database. Then we talk about the challenges, and then we look at database management system, as well as the future of databases. Future of database. So moving on to introduction. So a database is actually information that is set up for easy access, management, and updating. When you say database, actually, just as the word itself says, if you look at it closely, there are two words that made up the word database. There is data and there is base. So a database, if you look at it, looking at the word, you see you can say it is a base, right, of data, like somewhere, like someplace, somewhere, right, a base where there is data actually. So a database is information that's set up for easy access, management, and updating. So here, this statement says database is information, but if you're wondering, like, okay, database and information, yeah, we can, it's an information, because like, okay, there's a two difference between data and information. Data is raw, like the raw materials, right? Like it's like a raw material. When the raw material is processed, after processing, it will give you information, right? It will give you information. For example, like you have a student in a school, right? Okay, these students are of two genders, either male or female, right? So the number of male students that are taking mathematics or that are in class 1, the number of students that are in class 2, the number of female students that are in class 3, number of female students that are in class 4, and all that, if you put that, okay, then the number of students that are doing mathematics, that are doing English, that are doing chemistry, or that are doing any other subject. So all these are data, right? But when you process all this data to get a certain information, to get a certain outcome, that is information. So from that, you'll be able to determine, oh, so number of students in so school are doing mathematics. Consequently, this is the outcome of it, or this is what you have to expect, or this is what you have to plan for. So that is information. So you use that to take decisions. You choose information to make decisions, So that is one thing with database. That is a component of backend. So we're going to look at this today, a database as a component of backend application development or backend technology. right? So computer databases typically store aggregation of data records or files, mind you, data records or files that contain information such as sales transactions, yes, customer data, financials and product information. Absolutely. So a database basically is designed to hold such information, such data, such collection of data, such information. Yeah, which includes sales transactions. Yeah, sales transactions involve, okay, the date that the transaction is being executed, the time it is being executed, probably the location it's being executed, and then the people that are being involved, right? The product, the price, the quantity. You see, all these things, the quantity, the amount, and so many other things. Like all these things I mentioned on their own, they are data. Without collecting them. So when you put all that together and then create a database where all this information will be compiled, will be stored, will be compiled, will be stored, will be stored, will be stored, that makes a database. It can also be customer data, data about your customer. Okay, the name of your customer, the address of your customer, the contact details, which include maybe phone number, email address of your customer, and so many other things. So you have a record, you have a place where you maintain all those kind of information about your customers. That's a data. That's a database. Likewise, the product information. When we talk of product information, we talk about, okay, the manufacturing date of that product, the manufacturing year, right? The place of manufacture, the manufacturer, the quantity, the quantity, and depending on the product, as well as, yeah, depending on the product, okay, like the health benefit, okay, the ingredient that make up that product, okay, the other different parts of that product. So all these kind of things, they are information you require a database for. If you recall from our from our practical classes, we were working on developing an e-commerce system, right? An e-commerce system. If you look at closely, all this is related. So when you're developing an e-commerce system, you probably are going to have a back end, and that back end, there's going to be a database, and that database, of course, something like sales record, it's actually going to be very important to be there on that database. Customer data also, on the other hand, is relevant for that kind of system to have it in the database, as well as product information. It's also very, very vital, very, very key to be on that database. All right, so let's move on. Databases are used for storing, maintaining, and accessing any sort of data. So that is what the database is used for. It is used for storing, yes, storing information, and maintaining information. So when you just store the information, you just don't store it for storing purpose. Yeah, you store it for a reason, right? You store it for a reason, you store it for a purpose. So that is basically what you use the database for. All right, and then accessing the information at any point in time that you wanted. Yeah. So databases, they collect information on people, places, or things. This information is gathered in one place so it can be observed and analyzed. Yes. So databases can be thought of as an organized collection of information. Simply, that is what it means. All that English, that's what it means. So next, databases are essential for storing large amount of data in one place. With databases, organizations can quickly access, manage, modify, update, organize, and retrieve their data. Additionally, databases are normally controlled using a database management system. We are going to look at that closely in this database management system. In the database, data is organized into tables consisting of rows and columns. Usually, that is RDBMS. We will look at them. Many databases also use structured query language, SQL. So we will look at that also, what that SQL is for writing and querying data. So we are going to look at that. In the previous practical class, we looked at implementing a database, right? Using RDBMS, MySQL to be specific. We saw how we can create a database from a UI and then create tables on the database and also add data to that database. We saw how we can do all that. And then we also saw how when we do that using the GUI, the DBMS, we see how it generates the equivalent SQL for the operation that we've done. How it generates an equivalent SQL for the operation that we've done. So we are going to be explaining that. There are different kind of databases. However, so the exact language used and how it works depends on the type of database. So what this means is that there is a structured language that is used to communicate with databases. There's a structured language that is used to communicate with the databases, which is the SQL mentioned earlier. So there are different databases. We have the SQL, right? We have MySQL, we have SQLite, we have PostgreSQL, we have a lot of them. All these languages, they are relational. So, and it's only relational that uses this language to be specific. It's relational languages that can use the language to communicate with. So let's look at the uses of databases. Uses of database. We are trying to make some sense into understanding why do we need these databases? Why and how are they component of back-end application development? So that is what we are trying to see. That is what we are trying to do, trying to make sense of all these things. Yeah. So businesses, government, and scientific fields use database for data storage. They use it for analysis as well as management. So the use of database is actually cannot be overemphasized. That is the truth. When you want to work and you don't have a database, I don't think you are ready to work. That's the truth. So if you see, and it's not limited to any other field, because in the field of business, government, and scientific research and whatever scientific activities use databases for data storage, data analysis, and management. Organizations use data stored in databases to make informed business decisions. Some of the ways organizations use databases include the following: to improve business processes. Absolutely. So companies collect data about business processes. As you can see, I highlighted business processes. I highlighted and underlined business processes here. It's because of how important it is, the business processes. So what do we mean about business processes? For example, in relation, I'll always make reference to the practical class we are doing in respect of the development of an e-commerce website. So we have what we call sales and order processing, right? You are in a business, you are dealing with people, you are dealing with customers, you are selling, be it services or a product, right? So it's always good, it's always best to have a database to maintain that. The records of sales. Okay, what have you sell? What product have you sell? When was the sale? When was the sales? How much was the sales? How much did you realize from the sales? All that. Very, very key. All that very, very important. Who was the salesperson that said? Who made the highest sales among your staff, your salesperson, and all that? Making that is very, very key. You have to have a record of that. It's good. Have to have a record of that. And then order processing and customer service. So, okay, you are delivering, is it a service? Let's say, okay, you're delivering a service, right? Or a product. Okay, who made the order? Who made the orders? When was the order made, right? How many orders were being made? So you have to track record of all that. You have to track record of all that. Okay, just imagine you are doing a business, right? And then there were orders that came in, and then you don't know who made the orders. You don't know when was the orders made, right? You don't know how the orders came. Then there's an issue. Then you're not in business. You are trying to be in chaos, not a business. So we have to have a database for all those kind of things. They analyze the data to improve these processes, expand their business, and grow ventures. So basically, with these records, with these data in the business, you can analyze these data to get a lot of information. Information like what? Information like, okay, in this month, how many orders did I get? How many people made these orders? From which location did they make these orders? Okay, is it the man or the woman are making most orders of this particular product, right? How much did I realize in revenue from this product, from this particular product? You understand? Okay, how much is due from me for tax from this product? You see, all this kind of thing. Okay, how much did I make profit in this product, in these services and so many other things? Okay, what do I need to improve to make this product sell more to this particular category of people? You understand? So those are what we are talking about. So those are the kind of analysis to expand to expand their business and grow their revenue. That is what we talk about there. So next we go on to the next use of a database. Keep track of customers. I don't know whether you noticed a lot of service providers on the internet, right? A lot of services that you try to subscribe to online and all that. First of all, you must have to register. You must have to register your email address, your name, and some other information they require. So they do that to keep track of customers, to keep track of clients. That is the sole purpose of why they do that. And they have their reasons for that. Databases often store information about people, such as customers or users, right? For example, social media platforms use databases to store user information, such as names, email addresses, and user behavior. I don't know whether some of you have ever wondered how it happens that When you search for a certain product online, maybe let's say in an e-store, you search for a certain product, or let's say, let's use the other social medias, you search for a type of content, right? And subsequently, you keep getting the same kind of content. The same kind of content will keep popping up to your screen as suggestions, as recommendations. Have you ever noticed on that? For example, the videos. Let me give you this clear example. For example, the videos you watch on YouTube, the videos you search on YouTube, you watch on YouTube, right? So you see that your content on YouTube, the video suggestions you always have on YouTube are related. They are similar. They are similar content, related content, right? They are exactly similar. Even if you logged off your computer and go to a different location and use another person's computer, as long as you logged into your YouTube account, you still see those kind of videos pop up. Whereas when another person on that same computer uses his own account, you see different suggestions of videos. Why? It's because from their database, right? They have stored like records of your behavior. They've seen what you wanted and they'll be giving you suggestion to that to keep you coming back, to keep you hooked on, right? So that is why so there's a database behind that. And additionally, with the introduction of artificial intelligence, right, it has even become more, how do I even say it? It has even become more seamless for the system to do that. So it learns. So the system learns about you. It understands you. It learns that, oh, this person likes this kind of content. Okay, let me keep feeding in with this content. Let me keep feeding it continuously. If you yourself don't slide out, the system will never get tired of, will never get exhausted of suggesting to you what content to consume. Yeah. So that data is used to recommend contents to users and improve the user experience. Yeah. So for every single thing, there's a good thing and a bad thing to it. So the good thing to it, it's usually used to improve. It depends on how they use it, right? Are they using it to improve user experience? If they're using it to improve user experience, that's a good one. It's a nice one. Are they using it for some kind of benefit to them, for some kind of reason, or whatever kind of thing they want to do? That is their own. So another uses of database is secure personal health information. Healthcare providers use databases to store personal health data to inform and improve patient care. For example, hospitals. Of recent, I've seen a whole lot of hospitals migrating from the traditional way they keep records, to digitizing every single thing. 15, 20, more than 25 years ago, when we go to hospitals, we go to a particular room, right? Particular location where that room is completely filled up with files, with files and papers. So we go, we give them our numbers, they ask us for our hospital number, we give them our hospital number, they go inside, they try to go and check the files for our file number. When they get our file number, they come back with a file in their hand. They give us and then told us to go and see the doctor, go and sit down here, and then they'll take it, they'll take it to the doctor. So that was the traditional way. However, recently, well, I still don't know if there's any other hospital that still operates that way, but presently, think almost all hospitals I know they've moved to the digital platform, keeping up with the trend. So that is great. So that hospital, those hospitals, they maintain a database. You are not the only patient that is coming to that hospital. They have hundreds and even thousands of patients, some hospitals, and they always have your records. They always have it, even to the smallest prescription of Panadol the hospital gives you. They should have that in your record. They should have that in a record. All that is in a database. That system they are using has a database behind it, right? It has a database behind it. So that database contains every single information about you, from your name, your date of birth, to your age, to your gender, to your blood type, to your height, right? To any history of sickness you've ever had in that hospital, right? To any single history of prescription that the doctor has given you, any injection and everything, with including the date. Everything is there in the database. Everything is there in the database. So that is it. So this information is secured, right? So, and that is to improve patient care. That is the reason why they have all that, is to improve patient care. In the way to improve patient care is like, the doctors are not always constant, right? They are not always same doctors you go to see. Probably a doctor that worked in this hospital might probably decide to say tomorrow he's not working in this same hospital, he has gotten another appointment in another hospital, or it might not be his shift or whatever, and then there are new doctors that will keep coming in and all that. So when you want to see a doctor, it doesn't have to be the same doctor you've seen previously. To say another different doctor can continue on your case, and then it will be as if he was right there right from the beginning. Because once he have a view of your case file in the system, and they look at everything, the history and everything, he'll be brought abreast with your case, and then he can continue from there, because he knows right from day one, this is what you've been battling with. Okay, this is what you've been diagnosed. This is the treatment you are undergoing. This is the medication they are giving you. You are at this stage. Okay, they're giving you this. This is how you react to it. So he knows every single thing. So he can now say from here, okay, let's move on. Let's go to the next. So that is basically how we improve healthcare. So next, another use of database is to store personal data. Personal data, such as probably your name, age, date of birth, your biodata, right? Your academic qualification, your academic related data, your health related data, your everything, like everything about you, like is a personal data. So databases can also be used to store personal information. For example, you have a file that contains everything about you, your blood type, your genotype, every single thing. You might decide to maintain such information for yourself. Personal cloud storage. I underlined cloud storage and highlighted it for one reason. Because presently, all of us, I will not say almost, okay, let me say almost all of us have access to cloud storage that we store our personal files to it. A lot of us have Google account. We have Google Cloud Storage, right? For those that have iPhone, iOS, you have the iCloud. You can store a lot of your files. If you are in school, you store your assignments, you store your coursework, you store your projects on these clouds. As a working class person, yes, you store your vital office documents on this cloud. You have access to them anywhere, anytime. from any location, right? So we all have access to this. Personal cloud storage is available for individual users to store media. Yes, we do have our medias stored on them, our photos, our videos, and all that on the cloud. So it's almost available. It's readily available to everyone. It's readily available to everyone in the cloud. Yeah, like Google Drive. Absolutely, like Google Drive. Google Drive is one of the best example of that. So you can store a lot of those things. So it's like that. You can use a Google Drive as your database, right? It can hold all the data. You can have all your files back up to it. You can store them there. You are secure. You are covered. You have nothing to worry about. So that is it. Yes. So now let's move on to the types of databases. So earlier on, I mentioned database are of different types, right? And these types might be categorized into what we call the relational. Relational basically means table, right? So it basically means table. That is what relational means. Relational database. It's the same thing as saying table database. In this type of database, data are stored in form of rows and columns. Rows and columns. So a relational database, this tabular approach defines data so it can be reorganized and accessed in several ways. Relational databases are comprised of tables and data placed into predefined categories in those tables. Each table has a column with at least one data category and row that has a certain data instance for the categories that are defined in the column. Information about a specific customer in a relational database is organized into rows, columns, and tables. So what does that statement mean? What does that mean? We say a table database, right? So what it means here, relational databases, what it means here is that data is stored in the form of table, rows, and columns, right? For example, now you are running a business, let's say a school business, right? So, and you want to create a database, or let's say you have a database. So your database, you are going and you are trying to work with a relational database. I remember we mentioned relational database has a tabular approach, right? Has a tabular approach in tables. So how are you going to handle that? The way you are going to do that is you are going to have a table, right? You are going to have a table for students. So the students, the table students will hold the information about students, like everything about students, the student name, the student age or date of birth, right? The student's address, the student's phone number, right? And other relevant data that you feel will be key. All right. And then you are going to have another table that says staff, right? Yeah, you have like teaching staff and you have non-teaching staff. Mind you on that. When you call that table staff, you are going to have teaching staff and non-teaching staff, right? So again, you can go ahead and break it. I'm not going to go deep into that because I know you have a course database on its own. So I'm sure pretty now by then they would have explained. You would have been taught all that. You would have been taught all that. So when you have another table called staff, and then you break it down into teaching staff and non-teaching staff. So here, the database we're talking about, right? You'll be wondering, but you are mentioning database, and then you are saying student table, and then you're coming and saying staff table, right? Probably you have course table, where you have the courses for your school, which involve the course ID, right? The course name, course description, as well as the class or semester, or depending on the type of school, whether is it a higher institution of learning, or is it a secondary or elementary, right? So you're going to have all those information, right, in the database. So basically, what I said in here, talking about databases, and I'm talking about tables, different tables. So if you understand, if you are with me on this, you understand that a database is a collection of tables. A relational database is actually a collection of tables. It's a collection of tables. So in your business, you have different tables for different things. So for example, looking at the e-commerce system we are trying to design, we are going to have a table for users, right? We are going to have table for users or customers, which that table is going to contain the customer name, the email address, the password, right? When the customer registers on the system, of course, you use the email address and the password or whatever username, or how you design the system, or username to log in into the system, right? So additionally, that user after registering is going to be customer, right? So they now add other information relating to the customer, relating to the business, relating to transaction. So yes, what type of product does the person buy? How many of the product does he buy? You see, like sometimes you can go extra mile to take record of login details. By login detail, I mean when was the last time that customer, that user logs into the system? It's there. It will take record of that. Okay, when was the last time you came on the system? So it's there. It's all there on that. Yeah. So that is that. So what I want you to take away from this statement is that a relational database, is a collection of tables. Is a relation of tables of related data put together that makes up a database. You understand? So that is it. And a relational database are in the forms of rows and columns, in the forms of table. Yeah. So these are indexed to make it easier to search using SQL. So these data inside the database, there is a structured way we communicate with them as humans, we communicate with the database. If we want to create a table inside the database, there's a language that we send to a particular database management system. We call that DBMS. We'll also look at that going forward. There's a language we tell the DBMS. The DBMS will create the database. There's a way we talk to the DBMS. It will create the table. There's a way we talk to the DBMS. It will insert records or data into the table. There's a way we talk to the DBMS. It will update the records for us in that database. There is a way we talk to the DBMS. It will delete the record. So that way of talking to it in RDBMS, that is the SQL. That is the SQL, the structured query language. Yeah. So let's move on. So next, relational databases. Relational databases use SQL in their user and programming application interface. So that is what we mention, the SQL. So the SQL is the language that we use to communicate with the database in their user and application programming interfaces. A new data category can easily be added to a relational database without having to change the existing application. A relational database management system is used to store, manage, query, and retrieve data in a relational database. So now, like I mentioned earlier, when you have a database, right, and your database you are having is a relational database. Relational because it's collection of tables, right? It's a collection of tables. So that environment that manages everything about your data, that manages your database, is the database management system. For relational databases, we call them RDBMS, to be specific, right? For relational database, we call them RDBMS, Relational Database Management System. This RDBMS has a functionality to store the data, right? To manage the data whenever you want it, and then query the data and retrieve data in the relational database. Typically, the RDBMS gives users the ability to control read-write access, specific report generation, and analyze use. Some databases offer atomicity, consistency, isolation, and durability, also known as ACID. Compliance to guarantee that data is consistent and transactions are complete. Are you with me? Are you all with me, please? Are we on the same page? All right. I guess we are good. All right. So let's move on. So for the types of databases, we also have what we call distributed database. This database, that is the distributed database, right, stores record or files in several physical locations. Data processing is also spread out and replicated across different parts of the world. Distributed databases can be homogeneous, where Sorry about that. Distributed databases can be homogeneous, where all physical locations have the same underlying hardware and run the same operating system and database applications. So basically, when we talk of distributed database systems, right? These are databases that are being spread across geographical location, different geographical locations. That is an example of example of distributed. Is distributed across different locations. That is distributed database for you. So, and these distributed database, they can be heterogeneous in the sense that the hardwares, they can be homogeneous first of all. Let me use homogeneous. They can be homogeneous in the sense that the hardwares the database is run on are exactly the same across, right? Across the different location, right? The operating system those hardwares are running, right? They are the same across those locations. And the RDBMS, and the DBMS, the database management system, also they are the same across the different locations. They are going to be the same. So that you call them homogeneous distributed database. And we also have the heterogeneous. In this case, the hardware, the OS, and the database application can be different in various locations. So when you talk of the heterogeneous, database, right, the hardwares might be different. You might be running on a physical machine from HP, and the other location might be running on a different hardware machine from Dell, right? You see, these are two different hardwares from different manufacturers. So that is a heterogeneous. You fall that into a heterogeneous category. It might be the operating system. It might be the operating system that the databases are running on. One location might be running on Windows, right? One might be running on a Linux machine. So you see, there's a difference in terms of that. Another one, might be the DBMS, the database management system. You might be using different DBMS. We have SQL Server, right, as one of the DBMS. And then we have PostgreSQL, right? We have SQL Workbench, right? So, and the rest. So when you have these DBMS from different vendors, different manufacturers, so that's heterogeneous. So that's that. So let's move on to the next. So in the types of databases, we have cloud databases. So the cloud databases are built in a public, private, or even hybrid cloud for virtualized environment. For example, citing the examples I gave earlier, like the cloud storage, right? Where we mentioned the Google Drive, the iCloud, and all that. So that might be a clear example of a cloud database, which are built in public, private, or hybrid cloud for virtualized environment. Users are charged based on how much storage and bandwidth they use. There are other database service providers, like we have MongoDB. MongoDB is actually a NoSQL database, right? They have an online service. where you can have your database for your project. It can be online. We have a Firebase also. Firebase also is an online database. Yes, it has also cloud services. So yeah, that is that. They also get scalability on demand and high availability. These databases can work with applications deployed as software as a service. So mind you, the as a service offering is typically called database as a service, where you get database services, right, as a service. So that is called DBAAS, database as a service. So you just subscribe, and then you are given the product to serve you, or you are being provided with the services for databases. So we call that database as a service. Moving on, also on the types of database, we have NoSQL database. Remember, earlier on, we talked about relational databases, right? Where we mentioned that relational databases are databases in tabular form, right? In the forms of tables, where data are stored in rows and columns. Aside the SQL database, the relational database, we have NoSQL. Why do we call them NoSQL databases? The reason why we call them NoSQL databases, it's because they do not follow the approach of SQL. There's no specific language that we use to communicate with that database to perform a certain operation that we desire. For example, there's no defined language structure for creating the database, right? There's no defined language structure for creating a table in the database, for manipulating the table, as well as for deleting the table. So that is it. So NoSQL databases are good when dealing with large collection of distributed data. See, everything has its advantage, right? So for NoSQL databases, it is good when dealing with large collections of distributed data. They can address big data performance issue better than relational databases. Additionally, NoSQL also do well in analyzing large unstructured data sets and data on virtual servers in the cloud. These databases can also be called non-relational databases. These databases that we call NoSQL databases, they are called unrelational, they can be called non-relational databases. Example of these types of database, we have MongoDB, right? We have Cassandra, also is a NoSQL database. We have Firebase. Let me show you an example of how these databases look. We also have Firebase. So let me show you how it looks. Let me show you how it looks. And go to firebaseconsole.com. Okay. So let me use this. So Firestore database. So now look at this. This is an example of how NoSQL database looks like. We call that a document type database. That is what we call that, document type database. So, and this is a Firebase, Firestore. So look at the screen now. Here you see this is the database. It has been created, but inside this database, I have two collections. Mind you, in relational database, we call a collection of data relation, right? Whereas in NoSQL, we call them collections. So in this database, I have two collections. I have applicants and I have attendees, right? All right. So let me open collection of applicants. So inside the collection of applicants, these are the applicants. Then we have what we call documents. So for each collection of a particular data relating to that applicant, we call it a collection, we call it a document. So inside this document, oh no. These are real details. No. Let me change the database. These are actually data that should not be seen. You can change the database. Let me look at this. Okay, so let me just cite you the example with these data. Sorry, my bad. I wasn't supposed to let that. I wasn't supposed to show you that example based on that data. Sorry about that. So here we have two collections in this database, right? And the two collections we have users, we have estates, right? So inside users, there's a document. So for every particular user, his details, everything will be under that particular user document. So now inside this document, right, we have this data, we have these fields. We call each data, we call them fields. We have email, right, which goes admin01 at vms.com. That is a field, right? An email. We have name, admin01, right? And we have a role, admin. So what you see here, all these three, 1, 2, 3, they are fields. We call them fields. However, these fields, as you can see here, we have, let me use the word title for now, for explaining it to you. We have the email, right, which stands here as a title. We have this admin01 at vms.com as the actual email, right? So this field is categorized into two, as you can see. So we call this key rather than title. We call this key, or we call this value. So that is how it is in NoSQL database. We call this field, we call this key, email, name, and role are keys. Right? Are you following? Are you with me? Is everyone with me? All right. All these ones, they are keys. Email, name, and role, they are key. On the other hand, this admin01 at gmail.com, admin01, they are values. So that is how data is being organized. That is how data is being organized in a NoSQL database. We call this a document database. So it goes like this once again, a collection, right? Okay, for example, let me show you a quick example. All right. So now I want to create another collection, right? Start another collection. This collection, we call it students. All right. It said collection ID. We call it students, right? We call it students. And then click next, right? So there's a document ID. Document ID can be anything. If you want the system to auto-generate for you, if you want this system to auto-generate for you, it can auto-generate for you by clicking here. It can auto-generate a database, sorry, a document key for you. And you can type the document key by yourself as you wanted, right? So for name, right? Sorry, for the fields, which is under this document ID, we have the field, you see, right? We have type. Type basically means data type. You know, when you talk of database and when you talk of database, to be specific, every kind of data has its type, right? Every kind of data in programming, every kind of data has its type. We have the integer, we have boolean, we have strings, right? We have float, we have long. So there are different data types that do exist. So that is what this means. So we have string, we have number, we have boolean, we have map, we have array, null, timestamp, geopoint. All these are data types. So basically in this field, right, we can say because we are creating a collection, students, and then there's a document ID, right? So let's say now in this collection, this document, what are the fields that will be related to student? So of course there's name, right? Student name. In the value we can say John. We can say, the value we can say John, right? We can add field, let's say student ID of the value of the type string, right? We can say John at school. You can say John at school.com. We can add another field, right? Let's say email. John should have an email. Sorry, no. Value here, student ID, right? Value here, student ID should be S for student, right? 00012 3. Let's make this the student ID, right? And it's an example. So for the next field, we have email of type string. We can say John at students or John at school, SCHOOF, John at school.com, right? That's an example of an email address. So for the next field, we might decide to say age or date of birth, or let's say age. All right. I'm sure you've been wondering the type. All the type here is saying string, right? Name string. Name is a string because it's a collection, because it's a word and a collection of words, right? So student ID can be alphanumeric. Yeah, it can have letters and numbers. The student ID, right? And sometimes even forward slash or hyphen. So special characters. So because of that, it's also a string. It can be a string. Email address too can have a collection of, can be alphanumeric. Email address can be alphanumeric and also have special characters like dot. Yeah, we have .com, or some people, or some, there's a lot of organizations when they are generating a staff email address, there's a format they usually follow: surname dot first name, right? So that is that. And there's the @ symbol in email address, which is a special character also, right? So because of all that, email address is a type string. But age that we are using now, age is a number. There's no letter that can be attached to somebody's age. We cannot say, oh, that man is 53 years old, or is 24 years old. It's not possible. Age is a number. So it has to be 10, 20, 30, 40 is an integer, right? So because of that, we select the type here as number, right? So we can decide to say 24. Okay, so I have a question here. The question goes like this: Emidos crime. So the question goes like this: can non-SQL databases handle the storage of data from companies with hundreds of millions of pieces of data? For example, transaction data from Uber? Absolutely. 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 It can handle hundreds of millions of pieces of data. In fact, it's even more, should I say, reliable to handle those kind of data, because I don't know whether you've seen before, we mentioned it, it's reliable to hold much larger amount of data. It's reliable for holding larger amount of data. Yes. So you can use NoSQL for that. You can use NoSQL for that. It can handle that. And I don't want to sound not sure, but I think most of these companies that deal with high volume of data, in terms of millions of records, I think most of them, they use NoSQL databases. They use NoSQL databases. Okay, look at this on the screen. So the NoSQL databases are good when dealing with large collection of distributed data. So yes, it's you can use that. All right. So back to our example. So now age, right, is a type number, and then of value 24. So when we press on save, okay, so look at how this information appears. Look at how the collection arranged the data. It's not in table, right? So we have the collection here, students collection, which is basically like saying student table in a relational DBMS, right? All right. So next, inside the collection, we have a document, right? This document will hold the data relating to a particular entity. When I say entity here, to a particular, let's say, is it a particular student? Are you understanding what I'm saying? To hold a particular student. So for this student, right, this is the data inside this document collection. Age of 24, right, with an email of john@school.com, right? Then John, name, right? And then the student ID, there's S000123. All right. So if you want to populate this, this data with more data, like you can come here, click on add document, right? If you want to auto generate the document ID. You click on auto generate here. Else, if you want to provide an ID by yourself, let's say any other type of, let's say you've designed a format that you want to create those ID to be in that format, you can give it. But because I don't have any format now, I want the system to auto generate a document ID for me. So in the field, I'm going to add name like I did earlier, and then name, we can say Abu, right? Okay, then email, right, of string, you can say abu at school.com, right? And then for next we have what did we even after name, email, we have age, but I think age was the last. Okay, let me just add the age and then number, right? We can go and say 20. Complete save. So okay, let me see the last data that we added. Age, email address, name. Okay, student ID, very key, very key. So now phone number with a null option. No. It was not phone number. It was student ID. All right. So looking at this, right? So we are missing one field here. Previously, we added age, email, name, and the student ID, right? And here we forgot to add student ID. So to manipulate that, to do that, you just come here under add field, you create, and then you now type the student ID of type string. You can still say S0123 and say 122, and then press on add. So you see it has added. So this is how a NoSQL database is. A NoSQL database. So when you want to query data from this kind of database, there is no structured language, just like the relational that uses the SQL. So programmatically, as a programmer, if you want to query the collection of, yes, okay, I have a question here. The question says, could these databases still be controlled from an admin computer with a bash script? Yes, it can be controlled from an admin computer. Absolutely, it can be controlled. Yeah. So let's move on. So as a programmer, when you are developing a system that, for example, you want to, maybe as part of your system, there's a module that that you want to fetch all the data of the students. Already you know there's a collection called students, which is this, right? There's a collection that you already know called students. So you make reference to this collection, right? And then after making a collection to this reference, and then you can tell it, you can look through this, you can look through the document ID and ask the program to fetch you the name. So looping through it's not going to a specific student. It's not going to look for a specific student. It's going through number one. this document ID, it will fetch you the student name. It will come back to this number 2. It will fetch you the student name. If you have another one, number 3, it will fetch you the student name. If you have number 4, it will fetch you the student name. Or is it that you want all the fields on that is student document? It will still do the same thing for you. It will still do the same thing for you. You already know the collection. If you know the collection, then you can manipulate it programmatically from your code. Yes. So that is about what is it called? MySQL. Usually we call this NoSQL as a document-oriented database, because it's document-oriented, because all these things, these are the fields, they are stored inside this document. They are stored inside here, which we called a document. So let's move on. So they can address big data performance issues, right? Better than relational databases. So you see, back to the initial question I answered regarding hundreds of millions of pieces of data. Yes, NoSQL databases can handle big data performance issues better than relational databases. They also do well analyzing large unstructured data sets and data on virtual servers in the cloud. These databases can also be called non-relational database. Yeah, you can call them non-relational. So the relational, like I said here, the word relational, just switch it with table. Just don't get confused. Relation is table, tabular. Anywhere we hear database and relation, just put your mind to table, rows and columns. So that is just basically, and that SQL. And when you talk of rows and columns in database, when you talk of table, when you talk of relational, put your mind to SQL. Put your mind to SQL. Yeah, that is just the simple way to understand the difference. So next we are let's look at the components of a database. To have a database, right? First of all, you have to have a hardware. You have to have a hardware. This hardware is a physical device that the database software runs on. Database hardware include computer servers and hard drives. You cannot have a database where you don't even have a computer. It's not possible. You cannot have a database when you don't even have a computer. It's not possible. If you are subscribing to a database online, right? You are subscribing to a database online. Wherever you are subscribing to that database is hosted on a server, is hosted on a hardware in that place. You get? So either way, there is hardware. You cannot escape that. Next, you have software. Software, I mean, it can, in this context, can be of two different types. You can have the operating system, yes, because of course you cannot run a DBMS without an operating system. You cannot run a DBMS without having an OS. It's not possible. And when you have an OS, when you want to run a database, of course you have to have a DBMS. A DBMS is the database management system. So database software or applications give users control of the database. That is the software I'm talking about, is the DBMS. DBMS software is used to manage and control databases. So that is basically it. We have, for DBMS, we have a SQL Server. I believe an SQL Server is owned by Microsoft. It's one of the most popular DBMS system, right? And then there's Oracle. There's Oracle. Oracle is also owned by, I think the company is Oracle, right? That's the name of the company. Yeah. Okay, I have a question here. Grow with God says, please, can you define a schema? Okay, basically, in layman's or in simple terms, let me say like in simple terms, when you say schema, a database schema, it goes like that as database schema. Basically means like the structure. Put it at the back of your mind, like the structure of how your database should be, how your database tables should be. Okay, the database schema in the sense that structure in the sense that you have a name of type variable virtual, right? You have a name of type, you have an email of type virtual, right? And then in DBMS, in relational database management system, when you are creating a database, when you are creating a table for each data, you have to define some properties of it. For each column, for each row, you have to define the properties of it. What I mean by properties is, for example, when you are creating okay, let me show you an example. Let me show you an example right here. Okay. Okay. So let's take for example this table here, right, is let's call it a employee table, right, in your database. So you are going to have a serial, right, like a serial number 1 2 3 4 5 6 7 8 9 10 kind of serial number. In your employee table, you are going to have a name, right, employee name. You can decide to make it first name, middle name, last name, or you can just say full name. Anyhow you want to make it, you can just decide to say name. Let it be full name of the employee. You can have let's say date of birth. Let's call that DOB rather than writing it in full. Let's say DOB, right? You can say email. After email, you can say designation. You can say designation, right? After designation, then what? Okay, no, let's leave it at that. It's an example, right? So let's leave it at that. So this is how a simple RDBMS database is, like with this table. So all the data, everything are in this format, are going to be in this. So this is going to be 1 2 3 4 5 6, right? And then this one you can say John Abuja. You can say John Abuja, right? You can say Mark. You can say Musa, Abi. So let's leave it like this. Date of birth. So when you are defining these table columns in your RDBMS database, you are going to define some properties in addition to this. What I mean by some properties in addition to this is that this field you have to make it, you have to select you have to give it a data type. What type of data do you want that field to contain? That is one. If it's not a number, if it's not an integer, you will have to specify the number of characters you want to have inside that field, right? You are going to specify the number of characters that are going to be inside that field. Secondly, thirdly, you are going to specify the index of that column. By index, what I mean, is it primary key? Is it a foreign key? Is it unique? Those are what I mean by index. You are still going to define all those kind of things. For example, if it's for number, this serial, you can decide to make it auto increment, right? To increment automatically, not manually entering the serial. So all you need to do from your UI, you just provide it with the details, with the name of the person, the age, and all that. So in the database, automatically it knows this is number 7. Okay, this is number 8. This is number 9. This is number 10. So automatically on its own, the database will keep automatically incrementing rather than making it not auto increment. So you are the one that will have to say, okay, this is number 7. This is number 8. This is number 9. All right. So all those things you have to define. All those things you have to define the structure. So the structure is the schema, right? The structure is the schema and how it's going to relate with other tables. This is not a database course. However, I'm digressing a little bit further, but it's not a database. So from there, we look at relation to other tables. Relation to other tables. Using the primary key, the foreign key, and then you look at normalization. You look at database normalization and all that. So let's move on. You're welcome. So that is that. Here, secondly, we're talking about components, right? We're talking about software. Okay, the software we have is the DBMS. The DBMS stands for Database Management System. So basically, that is a software system that manages everything you need for a database operations. It manages everything you need for a database operation. Is it creating the database, creating the tables, populating the tables, inserting into the tables, editing the tables, updating? Is it deleting the tables, dropping the tables? Like every single thing. Is it creating another connection, another relation with another table? Like every single thing you need for the database operations, you have it inside that software. So that's the DBMS. We have SQL Server. You can go and check SQL Server. SQL Server is owned by Microsoft. Yes, it's a very good DBMS. It has been around for several decades. It has been around for decades. Yes. So aside that, there are others. There are SQL Workbench. We have MySQL. We have MySQL. We have PostgreSQL. There are others. They are numerous. So those, they manage database operations for you. All that. So, and then one of the key components, another key component is data. You have a database, but you do not have a data, then I don't know what to say. You can imagine. So data is the raw information that the database stores. Database administrators organize the data to make it meaningful. Remember earlier on I mentioned data are just like raw materials, right? They are like raw materials. On their own, they don't give information. They are just a collection of data, the collection of stuff, collection of records. That is just all. but it's when it is processed that it will turn to information. It's after those data are being processed that they turn into information. All right. So the next, as part of the component of the database, we have the data access language. This is one of the programming languages that controls the database. Yes, the programming languages and the DBMS must work together. One of the most common database language is the structured query language, the SQL. SQL is the most common programming languages for database interaction. You can call it for database communication, interaction, or whatever be it, you call it. So that is that. So next we have procedures. Procedures, these are rules that determine how the database works and how it handles data. That is what the procedures means in this case. Yeah. So next we have the challenges. Database challenges. Setting up, operating, and maintaining a database presents common challenges such as the following. Data security. Honestly, whenever you are trying to work with a database, whenever you're setting up a database, one thing you should always put at the back of your mind, one thing you should be conscious of is security. Security is very, very key. Always remember that we are at an era of the cyber environment, whereby a lot of things now are not just physical, like I mentioned. So you have to always think of the cyber world. Data security. Data security is required because data is valuable business asset. Absolutely. Data is valuable business asset. Protecting data required skills in cybersecurity, which can be costly. Absolutely. So you always have to. So when you're designing a database, you also have to design the security architecture at the same time. So next we have data integrity. Of course, it's another key issue that usually pops up in database. Integrity. What does it mean? What does it mean for you to have? What does it mean for your data to have integrity? To ensure that it is trustworthy, right? It isn't always easy to achieve data integrity because it means restricting access to databases to only those qualified to handle it. Yes. So you don't want everybody to have access to your data, to your database. I mean, it's not everybody should be able to manipulate your database. So if there are a lot of manipulators to your database, then there's going to be an issue with the integrity of your data, right? So next in the challenges, we have performance. Database performance requires regular database update and maintenance. You can't just create a database, right? You just create a database, you just populate it and then just let it be like that. You have to be maintaining the database. You have to be updating the database. Is it the DBMS to ensure performance, right? To ensure that your queries are being retrieved fast enough. Okay, to ensure there's no downtime, like the DBMS doesn't fail, to ensure that everything is running smoothly. So you have to maintain updates to the database as well as take care of the database. So without the proper support, database functionality can decline as the technology supporting the database changes or as the data it contains changes. You will believe me that previously, like 10 years back, 15 years back, right? The operating system we used to have then most likely are no more in use. Yeah, you might see them in one or two places. You might see them in one or two places, one or two people still using the operating system. But what I mean are no longer in use is the technology, the present stage we are at technology have moved past the level of those operating systems. Likewise, those softwares, those the DBMSs we use are always changing, are always evolving, So they might not be suitable to run on this kind of things. Because for example, SQL Server 15, 20 years ago is not the SQL Server it is now. Of course, there are a lot of advancements. There are a lot of advancements in terms of performance, in terms of security, in terms of so many other things. So many other things. So yes. So when you look at that, when you don't maintain those databases, the functionality will decline. Like for example, scalability. If you just take scalability for example, then can it accommodate up to like 10? Can it accommodate up to like 1,000 users at a time querying into the database at a time? No, because if you look at it presently, there are a lot of maybe sites on the internet today that is a global site, and per minute there are thousands of requests to those databases. If you don't upgrade, if you don't update to support, so the scalability, this you might end up having crashing database, right? In terms of performance, very very slow, very very disappointing, crashing, and all that. So that was one thing to that was one thing to that was one thing to look at, something like scalability, security, and all that. So yes, database challenge data another database challenge is database integration can also be difficult. It can involve integrating data sources from varying types of database and structures into a single database or data lakes and data warehouses. All right, I just finished talking about scalability, right? So yeah, here it is. Scalability is difficult for on-premises databases. It's challenging to predict the capacity needed. Absolutely. Cloud-based database don't have this issue to the same extent. So you see, when you are designing database, like looking at your target customers or target audience, you have to look at the issue of scalability. What I mean by issue of scalability, take for example a Jumia as an e-commerce website, right? Can you imagine the kind of people go on to Jumia or on Jumia per minute, per hour? Just look at that. You cannot determine you just imagine the number at a particular moment. Even right now, you can imagine across the world how many people are on Jumia. So if they don't have a database that would accommodate scalability, that large number of scalable people, then there's going to be an issue. There's going to be an issue. So that is that. So like we mentioned earlier, so the DBMS is basically a software that enables users to create or manage a database. It also helps them to create, read, update, and delete data in the database as it assists with logging and auditing function. A DBMS provides physical and logical independence from data. Users and applications don't need to know either the physical or logical location of data. Yes, presently that we do have a lot of service providers that give database services online. So you can just maybe probably subscribe, and then you have some database services online. So you don't need to know. So for users like that, you don't need to know the location of the physical location of where that database is. But that database do actually physically exist somewhere. It's coming from somewhere. The server is somewhere located physically. But you don't need to know where exactly it is. All you need to know, all you need to know is that you are getting the services that you paid for. You are getting value for your money. You are getting satisfaction. That is all that matters to you, right? So that is that. But actually, DBMS exists. So a DBMS can also limit and control access to the database and provide different views at the same database schema to multiple users. Example of DBMS include Microsoft SQL servers, MySQL, and Oracle database. So basically, this database is a component of backend application development. So if we look at it, when you are developing a software and you're developing a system, right? So for the back end, initially we did front end application development, right? So there's a front end and there's a back end. The front end, like we mentioned, comprises of the UI and the UX, what you see on your screen, what you interact with on the screen, right? And then in addition to the front end, there's a back end. Those two components, those two parts are what build a system, software system, online system, all that. So for the back end, it also has some components in the back end. That is why we are talking about database, which is one of the components of the back end application development technology. We have the back end, the database. We looked at the APIs the last time, the application development interfaces, application programming interfaces, the APIs. We looked at servers and we looked at programming languages. So all these things are the component of a back end. So you are developing a system, you have to a back end and a front end. And there are specialization for each. There's a back end specialization and there's a front end specialization. And in addition to that, there is the third one, which we call full stack. The specialization we call full stack. Full stack is a skill, somebody that can do both front end and back end. The person can develop front end and develop back end. So in the next practical class we are going to hold this weekend, by the grace of God, we are going to be completing our completing our developing the system we started developing this previous week. So this week the approach is going to be a little bit different because we are still moving a little bit slower behind schedule because we still get stopped, moving in crowd. So we have to be a little bit considerate. Not everybody can be on the same speed. So because of that, and the time frame we have is a little bit expiring. So the approach we are going to take this week will be different. I will provide the instructions. I will provide everything, the source code, everything. So we are going to explain it. So you are going to take it. I'll make it available. I'll make the resources available on the platform. So you can just go there, download, and then do the assignment based on the instructions, so that by the end of this weekend, we are going to make sure we have a functional system by the grace of God. So without further ado, we are going to stop here for this session. And at this point, I will entertain questions from us, please. If there's any question, please, I will be glad to entertain any question. Still waiting for the questions. Okay. In the absence of any other question, I've not received any question up till now. So in the absence of any other question, I think we call this session. I think we call it a day. So thank you very much. However, if there's any other question, maybe you can drop it in the platform, and we shall communicate to you by the grace of God. So thank you very much. Thank you for your time. Thank you for your understanding. Thank you for your patience. Thank you very much. Thank you, and God bless you.